Hello and welcome to this tutorial on building a Gaussian process model of the wind tunnel data and subsequent data merging. So we have our MATLAB window open. I'm going to run my trap flap 2D GP merge code, after which I'm going to let it run for a while and then talk later. As you can see from the MATLAB screen output, we have a Gaussian process additive combination of neural network plus squared exponential covariance kernels. The CFD simulation results calibrated the wind tunnel data Gaussian process surrogates. We're using a linear set of scale and location correction terms on the CFD results. The calculations here are for the spar or main wing section of the NASA trap wing. Note that for the pressure port bands closer to the NASA trap wing body pod or fuselage, there's a significant aerodynamic effect on the surface pressure values due to the interaction of the slat trailing edge with the spar leading edge, this rise and fall in the CP values. Another item of interest in the CFD results is near the arc length value of about 0.1. This data was removed because of the large CP spike at the cove corner. The CFD is not perfect at predicting flow separation or reattachment anyway, so this is a reasonable assumption for engineering. Let's look at the results from each pressure port band. The first pressure port band is at Y over B, or eta value of 0.17. The next one is for eta value of 0.28. Now, as you can see, the rise and fall in the CP value near the leading edge of the spar and trailing edge of the slat is reduced significantly. This continues until we reach the wingtip. Another point of interest is that the wind tunnel Gaussian process surrogate, the mean value, the red line here, seeks to approximate the wind tunnel data, the green dots, while using the CFD B-spline surrogate as a baseline. So if we go to eta value of 0.5, or the half span location, the wind tunnel data and CFD are almost lined up exactly, so the wind tunnel Gaussian process does not have to move much, but it still does a little bit, especially near the leading edge here. Here we have the Gaussian process at eta 0.65 and at 0.7. At 0.85, .95. As you can see, we start to have a few more deviations of the wind tunnel data away from the CFD. This was also noted in some NASA presentations regarding the trap wing data with the CFD predictions. The last pressure port band is at eta value of 0.98. And as you can see, closer to the upper surface trailing edge, there is significant deviation of the wind tunnel data from the CFD approximation or CFD results. This was not only from this one CFD bank, but from other CFD results as well. However, the wind tunnel Gaussian process does a pretty good job of approximating the wind tunnel data despite using the CFD as a baseline. The Gaussian process models are one-dimensional surrogates, in this case, along the wind tunnel pressure port bands. This work uses multiple 1D or one-dimensional Gaussian process models at the port bands and then uses an additive corrector method to calculate the two-dimensional wind tunnel surrogate. Let's look at that. So what the additive corrector method does is it takes the wind tunnel values, the wind tunnel Gaussian process prediction at each pressure port band, takes the shape of the CFD in the spanwise direction, and adds a corrector value, which we call beta here. Adds a corrector value using a least squares approach to approximate the wind tunnel values. Now, once all of these are calculated, these beta values for each arc length, we have multiple corrector values. Then we generate a B-spline of the corrector beta. And using that corrector, we then add that corrector to the wind tunnel, or to the CFD rather, and we generate a two-dimensional wind tunnel surrogate using Gaussian process models, multiple one-dimensional Gaussian process models for each pressure port band, and then an additive corrector method in the spanwise direction. So now we have a full two-dimensional wind tunnel surrogate. The wind tunnel surrogate and the CFD two-dimensional surrogate using B-splines are then merged using a weighted sum approach. Thanks for watching.